Ever wondered why heat flows from a hot body to a cold body and not the other way round? Well, that's a question that puzzled scientists for centuries. It's all about a fascinating field of study called thermodynamics. This isn't just some obscure scientific theory. It impacts everyday life in ways you might not even realize. From the way your refrigerator works to why it's hotter in the summer than in the winter. One of the key players in this grand play of energy movement is the second law of thermodynamics. It's the law that dictates the direction of heat flow. In simple terms, this law tells us that heat always moves from a place of high temperature to a place of lower temperature, never the other way around. That's why your hot cup of coffee cools down when left on the table. So remember, the second law of thermodynamics ensures that your coffee cools down, not heats up spontaneously. What makes a hot day hot or a cold day cold? The answer lies in the Zeroth law of thermodynamics. Now you might ask, why zero? Well, this law was established after the first, second and third laws, but it's so fundamental that scientists decided it deserved the number zero. Imagine a thermometer. When you place it in a hot cup of tea, the mercury inside the thermometer rises. Why? Because the Zeroth law of thermodynamics is at play. The law states that if two systems are each in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. Here, the hot tea and the mercury in the thermometer are the two systems, and they are reaching thermal equilibrium. Hence the mercury rises. This law allows us to measure temperature and understand the concept of thermal equilibrium. So, thanks to the Zeroth law, we can measure temperature and know if it's a hot day or a cold one. Energy can't be created or destroyed, only transformed. That's the first law of thermodynamics. Picture a car engine, a marvel of mechanical engineering. As the engine roars to life, chemical energy stored in the petrol undergoes a transformation. This energy, once dormant, now bursts into action, converting into mechanical energy that propels the vehicle forward. But that's not all. Part of this energy also transforms into heat, a byproduct of the engine's operation. This is the first law in action, the principle of conservation of energy. The total energy of the system, our car engine in this case, remains constant. It merely changes its form, from chemical to mechanical and thermal energy. No energy disappears into thin air, and no new energy materializes from nowhere. The first law keeps the energy books balanced, allowing our cars to run, our heaters to warm us, and our lights to shine. Absolute zero. A temperature so low, it's impossible to reach. That's the assertion of the third law of thermodynamics. This law boldly states that no matter how many steps you take, no matter how sophisticated your cooling techniques, reaching absolute zero in a finite number of operations is simply unattainable. Now, why is this so fascinating? Well, scientists around the globe are constantly pushing the boundaries of our understanding, and temperature is no exception. In laboratories, they strive to get as close as possible to that elusive 0 Kelvin, the absolute zero. The closer they get, the stranger things become. At these incredibly low temperatures, matter behaves in ways that boggle our everyday understanding, giving rise to phenomena like superconductivity and superfluidity. But no matter how close they get, absolute zero remains just out of reach. The third law reminds us that some limits can't be broken, not even in the coldest corners of the universe. From the heat of our coffee to the cold of outer space, thermodynamics rules our world. These laws are not mere scientific jargon, but the very codes that nature abides by. The Zeroth law, our bridge to understanding temperature, allows us to make sense of why your hot coffee cools down on a winter morning. The first law, the valiant conservationist of energy, assures us that while your coffee may lose heat, that energy isn't lost. It merely transforms, perhaps, into the whisper of steam you see rising from your cup. The second law, the silent director, dictates the course of this energy transfer, guaranteeing that your coffee won't spontaneously heat up on a cold day. And the third law, the elusive limit, tells us that even the coldest depths of outer space can't reach absolute zero. a theoretical limit we can approach but never quite touch. Next time you feel the warmth of the sun or the chill of a breeze, remember the laws of thermodynamics. They're not just theories, they're the rules that our universe plays by.